Image recognition, also known as computer vision, is the process of using algorithms and machine learning techniques to analyze and interpret visual information from images or videos. Here's a general overview of the image recognition process. Input. The process begins with the input of an image or a sequence of images. These images can be obtained from various sources, such as digital cameras, video streams, or pre-existing image databases. Preprocessing. Before the image can be analyzed, it often undergoes preprocessing steps to enhance its quality and remove any noise or irrelevant information. Preprocessing can involve operations like resizing, normalization, noise reduction, and color correction. Feature extraction. In this step, the image is analyzed to extract relevant features that will help in distinguishing objects or patterns within it. Features can be low-level visual characteristics like edges, textures, colors, or high-level semantic features that represent more complex concepts such as shapes or object categories. Feature representation. The extracted features are then converted into a suitable representation format that can be understood and processed by machine learning algorithms. Commonly used representations include vectors, histograms, or tensors. Training. In order to recognize and classify images, a machine learning model needs to be trained on a labeled dataset. During training, the model learns to recognize patterns and associations between the extracted features and their corresponding labels. This process involves adjusting the model's parameters to minimize the difference between predicted labels and ground truth labels. Classification, recognition. Once the model has been trained, it can be used to classify or recognize objects in new, unseen images. The model takes the preprocessed image as input and applies the learned knowledge to make predictions about the presence of specific objects or classes in the image. Post-processing. After the classification or recognition step, post-processing techniques can be applied to refine the results or extract additional information. This can involve tasks like object localization, identifying the precise location of objects within an image, object tracking, following objects across multiple frames, or semantic segmentation, labeling each pixel in an image with its corresponding class. Output. The final output of the image recognition process typically includes the detected objects or classes, their locations, and any additional information or insights derived from the analysis. It's important to note that the specific techniques and algorithms used in image recognition can vary depending on the application and the complexity of the task. Deep learning approaches, particularly convolutional neural networks, CNNs, have been highly successful in image recognition tasks in recent years, achieving state-of-the-art performance in various domains.